In this recording, I just want to review the empirical rule. Which is also called the 68, 95, 99.7 rule, because it divides the bell curve into three sections within 1, 2, or 3 standard deviations of the mean. The more perfectly bell curved your data is, the more accurate these values are. Excuse me. So let's look at the 68% first. See that in green? So that 68% is this center part right here. So that's the typical values from this data set. And it's surrounding the mean by 1 standard deviation. So if I add and subtract 1 standard deviation from the mean, I get the boundaries that show us our typical values within 68% of the mean. So this rule is telling us that 68% of the values are within 1 standard deviation of the mean, and 95% of the values are within 2 standard deviations of the mean, and then that's all we'll look at for right now. So then 95% of the data is within this area of the bell curve. So that includes that typical 68% and then some. That's our 95% of that. And then the 99.7% is actually telling us that within 3 standard deviations of the mean, we actually capture 99.7% of all the data. So that's almost all the data. It's quite unusual to get more than 3 standard deviations away from the mean, but it's possible, and that would be called an outlier. Now, our application of this within the scope of our Math 075 course, we don't really look at that, what's within that 95% very much. We look at that typical values, that's within the 68. So that's one of our calculations, is to add and subtract 1 standard deviation to get the typical values. And our other application is kind of an extension of this 95. If that 95 is between here, oops, sorry, wrong color, between 2 standard deviations of the mean, that means that 5% is in those tails. And that's really where we're using this 95 right here. So what does that look like? There we go. So that means if between these two green lines is 95% of the data, that leaves 5% of the data to be in these tails. But it's symmetric. So I'm going to split that remaining 5% into 2 and say there's 2.5% on the left and 2.5% on the right. And that is our unusually high values. And these are unusually low. Unusually low values. So that's where we use that 95 rule. And we are really not applying that 99.7% rule in the scope of this particular class.